Hi everyone. So today let's solve the problem 67, add binary, right? So this was this is fine. So let's solve the problem. So now what the question states here, we are given two binary strings a and b, right? So see here, we are given two binary strings a and b. Return the sum as the binary string. So we have to return their sum as the binary string, right? So all we have to do is we have to sum this one, right? So we have to convert this one into the binary, or we have been already given in the binary. All we have to do is we have to sum this one, sum up 1 1 and 1. So when we sum up this one, so we get the output basically 1 0 0, right? So 1 0 0. So the same thing goes with the example 2 as well. See here, so basically 1 1 this one 1 we have to go with a carry at the end, right? So this will be 1 1 will be this one will be 0 0, right? So this is fine. So the output here we have 1 0 1 0 1 0 1 1, and when we sum up this one, so this one will be 1 0, it will be 1 1 1, it will be 0 again, 1 carry basically 0, this one will be 1, basically we have got the carry, right? So this will be 1. So again now this will be 0, and finally we'll go with only 1. So this will be 1 0 1 0 1. This is fine. So they have given us wonderful examples just for the sake of understanding here. So this is fine. Sorry, just give me a second here. Yep. So let's do one thing. Let's quickly discuss the approach followed by the complexities, and then let's write the code. Simple. Let's consider the first example itself for the approach. First, what we will do, so we will be going with a bit manipulation to solve this problem, right? So we'll be going with a bit manipulation to solve this particular problem, right? So we'll start from the rightmost bit I, right? So we'll start from the rightmost bits I. So here in this case, so we'll be starting from 0 and 1, basically the rightmost bits, right? So the last ones basically. We'll start from the rightmost bits. I equals last index of a comma j, that is equivalent to the last index of b. So initially carry will be 0. Initially carry will be 0, right? So at each position we take single bit integers x and y, nothing but 0 or 1. We'll be computing the sum bit as this one, carry is 0 initially. We'll be computing the sum bit as x XOR y XOR this one, carry. So this is nothing but the XOR. So if you don't know XOR, so you have to know bitwise and this one, XOR, to solve this particular problem. So basically bitwise and this, let me write the truth table for bitwise and this one, XOR here. Let me write it this side so that we get space here, right? So this one, let me go with the bitwise and a, b, and the result, right? So this one is 0 1 0 0 1 0 1 1. Only when both are true, or only when we have this one a and b are this one, we have 1, then only the result is 1 for this one, else it is 0 for the bitwise and, right? So for the XOR, basically it is represented by this one, right? So I'll just go with the XOR here. So this one will be a b, again the result. So here let me go with 0 1 again, 0 0, same thing, 1 0 1 1. So only when two bits are different, basically, then only the result is 1. See here 0 1, so this will be 1. 0 0 we have same bit, so 0. 1 0, these are different, right? So 1, and 1 1 we have same, this will lead to 0. This is for the XOR, right? So this is fine, I believe, right? So let's move on with the further step. This is just for the just for your reference. So we'll be making use of the bitwise and XOR, basically. That is the reason I showed you here, right? So as I have said, we'll be computing the sum bit as x XOR y XOR carry, right? Nothing but the XOR, and we will compute the new carry as this one. We'll be going with x bitwise and y, or this one, or this one, x and basically x bitwise and carry. So let me close this one here, don't get confused. And finally y bitwise and, again let me write carry down, yeah, this one. So we'll be going with the this is kind of formula, basically we'll be going with, we'll be computing the new carry as x this one bitwise and y, or x bitwise and carry finally or y bitwise and carry, right? So we'll carry out from 3 inputs, right? So finally the final 2 steps will be, we'll be appending the computed sum bit to the string builder, and we will move left I minus minus, nothing but decrement j minus minus, will repeat until both the strings are exhausted, right? If a final carry is 1, then we will append 1. In this case we did the same thing, right? If the final this one, what do we call, if the final carry is equivalent to the 1, the value 1, we will append 1. Finally reverse the built string to get the correct code. In this case we have to do the same thing. You will get to know when we do this, right? So this is fine. Now we know the truth table. You can just pause the video and look into it if you don't know. We know what we need to use, right? So let's try to implement the same thing for the first example, right? So as I said, we'll be considering the first example for the approach. So let's do one thing. What was the first step? We have to go with the rightmost bit, starting from the rightmost bit, right? So we have x equals 1 and y equals 1. See here, the rightmost bit, this one and this one, we have only one bit here. So 1 1 we have, the rightmost is 1 and 1. X equals 1, y equals 1 here, x equals 1, y equals 1 here. And initially, as I have said, carry will be 0 initially, right? So we will be going with 1 XOR we have 0, right? So carry is 0, x XOR y XOR c, we will be going with the carry. So 1 x is 1, y is 1, carry equals 0. 1 XOR 0, right? XOR so this one this is equivalent to the 0, right? So this is fine, I believe this is fine. So next what we will do, as I have said, so we will be going with the this one, x ampersand y, then or this one x this one x bitwise and carry, or y ampersand carry. That is the formula that we went with here. In this case it will be 1 bitwise and 1 again, or here 1 bitwise and 0 here, 1 bitwise and 1, finally 0 ampersand 1. So this is fine, this is equivalent to 1, right? So we will append 0, we will be appending 0, right? So here this is equivalent to the 1. We know the truth table, so you can just calculate the same, right? So we'll get the 1 here. So we will be appending, so let me write this one as well so that we don't get confused here. So we will be appending 0 here in this case. This is fine. Now let's move on with the step 2 here. So we have x equals 1, y equals 0, and this one carry equals 1. Y we don't have anything, we have only single digit here. So x we still have one more digit here, right? So we started with the rightmost, we have to move with the next one, right? So now we have x equals 1, y equals 0, and the final one carry equals 1. So sum we will be going with here basically 1 XOR 0, basically XOR 1. So this will lead to 0. Carry will be, so this will be this step, we are going with this step, right? So this one will be 1 XOR 0 XOR 1 we have, so that led to 0. So this one will be 1 ampersand 0 x this one x bitwise and 0. Then we are going with the OR, this one 1 bitwise and 1, and finally OR this one y ampersand this one carry also we have to go with. Y is nothing but 0 here, 0 ampersand carry is nothing but 1 here. This is fine. This is nothing but 1 ampersand 0 is nothing but here x ampersand y, x bitwise and y, x bitwise and carry, y bitwise and carry. So we have discussed this one earlier, so this would lead to 1, right? So I have shown you this one as well, what do you call, truth table. So this would lead to basically 1, right? So again what we will do, we will append 0, right? So as we had the carry, so we'll append 0 here. So the final step here would be, so we will be going with the end here, basically carry is 1, so we will append 1, right? So we'll append 1, this is fine. So builder contains here 0 0 1. Builder contains 0 0 1. When we reverse this one, we get 1 0 0. When we reverse this one, we get 1 0 0. Right? So builder contains this one 0 0 1. So now we have 0 0 1, and as we had the carry, so during the approach I said we will be reversing when we had the carry, right? So this, when we reverse this one, when we reverse 0 0 1, we get the output 1 0 0. So now we have got the output 1 0 0, which is equivalent to the output that they have shown for the example 1 within the question. So our approach works absolutely correct here in this case. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities and then let's write the code. Right, so what would be the time complexity and the space complexity here? The time complexity would lead to big of n here, where n is nothing but max of a dot length and b dot length. A, this one, the length of the a and length of the b basically, right? Each bit is processed once here accordingly with the approach that we discussed. So what would be the space complexity here? The space complexity would lead to big of n as well for the output string builder, right? So the result length is less than or equal to n plus 1. So overall space complexity would lead to big of n. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively, right? So this is fine, I believe. So let me remove this one entirely. So now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So the first step here would be let's set the I and j to the last index of a and b. So this one will be int I equals a dot length minus 1, and also int j equals b dot length minus 1. So this is fine. Now let's go with the builder or the string builder here just to collect the sum bits as we discussed on the approach. So this one will be string builder sb equals new, let me type this one again, string builder. This is fine. The next step would be, let me go with the carry. So we have to go with the carry bit 0 or 1. Initially it will be set to 0 accordingly with the approach. So this one carry equals 0. We'll just articulate the same thing in the form of code, right? So that we discussed on the approach. So now let's process until both the strings are exhausted. So let me go with the while loop here. So this one will be while I greater than or equal to 0 or j greater than or equal to 0, right? So this one within the while loop, so we have to get the current bits x and y, 0 if index out of range, right? So this one will be int x equals I greater than or equal to 0. This is fine. A dot caret. So this one will be I hyphen 0 hyphen 0, else we'll be going with a 0, right? So we are just converting the char 0 or 1 to int 0 or 1, right? So this is fine. The same thing, let's do it for y as well. So this one y equals if j greater than or equal to 0, then what we need to go with, b dot caret of j. So this is fine, hyphen 0, else we'll be going with a 0, right? So this is fine, man. So let's go with the sum bit using XOR of the 3 inputs, x, XOR y, XOR carry. So that's what we went with, right? So I showed you step by step basically. So let me consider the variable name sum bit here. So this one will be 1 into x, XOR y, XOR let me go with carry here. Sorry, just give me a second, press something I think. So this one will be carry. Yep. Now after that one we have to compute the carry, right, using the bitwise operations. If you remember, x bitwise y, or x and this one bitwise and carry, or y bitwise and carry. That's what we went with, right? I showed you step by step. So this is nothing but the majority function basically. So let me go with the variable name new carry here. Let me represent the same here, x bitwise and y, or y bitwise and carry, sorry, so this one has to be x bitwise and carry. So the final one y bitwise and carry. So this is fine. Finally, let's append the sum bit as the character 0 or 1 to the builder, right? So this one will be string builder dot append. So this one will be char. This is fine. Yep, this is fine. So this one will be 0 plus sum bit. This is fine. So we are just appending in the reverse order, right? So this is fine, man. Finally, let's update the carry and move to the next left bit. So this one, let me assign carry to the new carry. So this is fine. We are just setting the carry for the next iteration. Next, let's move left in A, and next let's move left in B. So this one will be I minus minus and j minus minus. So this is fine. Let me come out of this one. So if the final carry remains, then we will be appending 1. So this one I can just write it on this way. If carry equals 1, then what we will do, so I'll just go with a string builder dot append here. So this one 1. So this is fine. We are just adding the final carry bit. So in this case, in the example 1 I showed, we did the same thing, right? So this was basically the wonderful example. This is fine. We considered the correct example, right? So this is fine. The final step would be we have to reverse the builder just to correct the order and return as string if we have the carry, right? So in this case, I'll just go with return string builder variable sb. I'll just go with the reverse here. Let me go with to string. We need within the string, right? So this is fine. Let me format the code once and let me hit the run button, man. So we have some error here. Let's check, man. Just give me a second. So what's wrong here? New, yeah, this B has to be capital here. Again, this is taking, yeah. Let me hit the run button. Yeah, the sample test cases are getting passed. Once the code works absolutely correct here, right? Let's see. Let's check whether this works for all the test cases or not. Let me hit the submit button. I hope it does. Yeah. See here, all the test cases are getting passed. So our code works absolutely correct. So whatever the code that we have written works absolutely correct for all the test cases, right? So this is fine. Let me close this one. Yep. Whatever the test cases, whatever the code that we have written works absolutely correct for all the test cases. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.